When someone with 4 decades of experience in the field says something like that, you listen. Every single catastrophic failure, it all starts with one simple fundamental concept being misunderstood. That's a heck of a warning, and it tells you that the biggest disasters, they really do start with the smallest mistakes. Let's get into it.
I mean, think about it. We live in a world run by numbers on gauges and readouts. We trust them completely. But what if the most important number, the one that really tells you if something is safe or not, isn't even on the dial? What if it's hiding in plain sight?
So, that's what we're digging into today, that hidden force, pressure. And we're not just talking about the basics. We're talking about a critical distinction that, when people get it wrong, has the power to turn incredibly powerful industrial equipment into a literal ticking time bomb. And let's be clear, we are not talking about some minor rounding error here. We are looking at a foundational, fundamental mistake in engineering, one that can have and absolutely has had catastrophic consequences.
The difference we're about to unpack, it's the razor's edge between a system that runs safely for decades and one that's a potential structural failure waiting to happen. It all boils down to knowing what you are actually measuring.
Okay, so before we can understand the mistake, we all have to be on the same page about the basics. So let's do a quick reset on what pressure fundamentally is. In physics, this is the classic definition, right? It's not just force, it's force concentrated over a specific area. Think about the difference between someone pushing you with their open palm versus with a single fingertip. It could be the same amount of force, but the pressure is vastly different.
And here's the math that runs the whole show. Pressure equals force divided by area. In the field, you'll see this measured in all sorts of units, like pascals, or bar, or maybe most commonly in some places, PSI, that's pounds per square inch. It seems simple, right? But that simplicity, that's exactly where the danger begins.
And here we go. This is the heart of the matter. It turns out there are 2 completely different ways to measure pressure. 2 different worlds, really. And confusing them, that's where everything goes sideways.
So the whole game comes down to their starting point, their zero. Gauge pressure, which is what most of the dials you'll ever see actually show, measures pressure relative to the air pressure around you. But absolute pressure, that measures it relative to a true perfect zero, a total vacuum. So one is what your local environment feels, and the other is what the universe feels. Big difference.
This diagram lays it all out perfectly. You see way down at the bottom, that's absolute zero pressure, a complete vacuum. A little ways up from that, that's our normal, everyday atmospheric pressure. Well, gauge pressure is the reading you get above that atmospheric line. Now, while there are a few ways to write out these relationships, the one key formula for structural safety, the one we're about to break down, is the one that connects all of these pieces together. The key to all of this, the key to understanding the danger, lies in a force that we can't see, that we can't feel, and that we almost never think about. The incredible weight of the column of air pushing down on us and everything around us. So let's break down the formula that finally accounts for it.
All right, first up, we have gauge pressure. Simple. This is the number an engineer sees on the dial of a boiler. It's tangible. You can see it. It's the pressure that exists above the normal atmospheric pressure. Next is the hidden variable, atmospheric pressure. It is constantly pushing on everything, including the outside of that boiler, with a force of about 14.7 psi right at sea level. This is the number that is almost never displayed, but it is always there. This is the number people forget. And then, when you add those 2 together, well, that's when you get absolute pressure. And this isn't some relative reading. This is the total, real deal, physical pressure that is being pushed on the walls of that vessel from the inside out. This is the number that decides if the metal is going to hold or if it's going to fail. And this just shows you the full picture beautifully. The real pressure your equipment is fighting against isn't just what the gauge says. It's what the gauge says plus the invisible but very real crushing force of the atmosphere all around it. Forgetting that second part, well, that's the fatal mistake. So let's take all this theory and connect it to the tragic reality. How does this simple misunderstanding actually lead to a catastrophic failure in something like a high-pressure boiler system?
It's a domino effect, really. It starts when the engineer sees the gauge reading and designs the system for that number, not realizing the true absolute pressure is actually significantly higher. Then, as the system gets hot, you get thermal expansion, which adds even more stress to the metal. And that combined force, the miscalculated pressure plus the thermal stress, it just overwhelms the steel's ability to contain it. The material's yield strength is breached, and the result is an explosion.
And that just brings us right back around to the core lesson from our expert. It's not about what the dial says in a vacuum, pardon the pun. It's about understanding the total, absolute, physical reality that the system exists in. And that includes the air we breathe and the constant pressure it exerts on everything.
Forgetting to add about 15 psi seems like such a small mistake, doesn't it? But as we've just seen, it can have unbelievable consequences. The most dangerous variables are often the ones we take for granted, simply because they're always there. And you know, this principle applies so far beyond engineering. It leaves us with a really critical question. In our own work, in our own lives, what's our atmospheric pressure? What's the invisible, constant force that we are failing to account for?